Okay, let's continue play with the functional programming paradigm and see what else we can do here. Now, one of the things that is being done on line 23 is that we filter through the to-dos, and based on the value of the filtered flag, we choose which one of our to-dos is going to end up in this array. Filtering is one of those very common tasks when you deal with any collections such as arrays. And so one of the things that's built into arrays in JavaScript is the filter operation. So to-dos filter, right? And this again follows a functional pattern. So it takes in a function argument and it returns a new array like filtered. Well, I called this filtered to-dos. Maybe let me call this like completed to-dos to just show you how you can get the completed to-dos out. So just like other functions for arrays, this takes this function, the functional argument, it will receive each element. So each to-do, it will receive it. And then if you return true, this to-do gets passed and it will go to the output. If you return false, this will be filtered out. So like right now, if I just keep it the way I kept it, this completed to-dos is going to be empty. If I change it to true, then it's going to be identical to the input. But what you probably want is something like this. You want to say if to-do completed, then return true. And otherwise, return false. And of course, this is a little silly because completed is already a boolean. So if something is true, return true, otherwise return false. Well, then you can just return that thing, right? We can just say this. Great. And the array functions, if you just have one return statement, you can take the curly bracket out, you can take the semicolon out, and you can take the return out. So it becomes really concise. You can even take this out. Okay, this looks really clean, right? Very concise, very clean. And so if like you wanted to get the active to-dos, you would just flip this. Anything that's not completed, right? It would be active to-do. All right, so if we want to get the filtered to-dos, basically, like if we think about, let's say there is a, like this is the process. I've got filtered to-dos, and what happens is that there's a function that takes the to-dos and takes the filter, right? And then it gets mapped to the filtered to-dos. So we can try to create a function. Let's call it like filter to-do. And so this takes the to-dos and a filter. And so we can say if filter is active, then now we can like do something like this. We can say return this thing. Else if, oh, forgot to put the arrow here. Else if filter completed, then do this thing. And else, well, the only case left is, well, there's no filtering, like all. You want to return all of it. So then we can take all of this out, the for loop, and replace this with a function. And basically call this, right? We don't need this stuff here. And so this, oh, we might have made a mistake somewhere. Okay, where is the mistake? To-dos, filter. Oh yeah, that's the mistake. We didn't call it like a function. There we go. So let's do a few other things as well. Let's like grab this inner functions and put them out. I want to sort of clean up the code that I have by kind of having these modular, small, really focused functions, right? And now this is getting cleaner. And let me also like change this to follow the same format as like the rest of them. All right, so everything still works the same, right? Let me actually show you something else that might be interesting. So like this thing returns an array, and then you bring it here and call map on it. We can just bring this here, right? We can like take one line off, and it's still the same. And we could even take this and bring it here. You see, like people who write functional code, one of the things that I've seen, they really like this style of writing, like chaining everything together, putting all of them in one pipe. And okay, we can even bring this to the top of the file where we have all of our like variables that we get hold of the elements. I think we even actually have that, right? To-do list element, isn't that the same as this thing? Okay, so we probably don't need this. We just need to make sure this is called to-do list. Okay, still everything works. Here's another one. Instead of these two, you can say, well, you can just take this out and you can say replace children. There you go. So like test T, there you go. Flip these things, filter them. Awesome. So cleaned up. Now I want to talk about one other thing. There's actually something that I'm not very content with here. Notice something interesting. When you do filter, what you're returning is not the original array, it's a new array, right? So filter returns a new array, kind of like what map does. And this is one of the, again, patterns that functional programming in particular embraces. It's this idea of immutable data structures, that rather than directly modifying a data structure, you make the modification but make a new copy of it. You return a new one. And this has some advantages and disadvantages. The obvious disadvantage is, while you would be using more memory, you got to copy, like if you have a very long list of array, you got to be copying everything out. The advantage is more subtle. The advantage happens generally when you want to, for example, debug your application. It is easier to capture the old state of the app if you modify, if rather than modifying the state, you keep it as an immutable state and you sort of make a copy of it. I'll try to show what that means here. This is a very simple app. It's hard to really show you a benefit of it, but at least on the surface, I'm going to try to show you what that means. So one thing, if we want to keep this consistent with what the filter does, we shouldn't be just returning the original one. We need to copy it and return it. And that's not a hard thing to do. You can just like say, hey, let me return a new array to you. And then you use the spread operator and you basically pan out the elements. I spread it out here, and so now my filter to do is a function that returns a new array. So all of these cases are consistent. Okay, the more perhaps obvious case is when we add a to do, and that must be here when we do new to do key down. So there you go, push directly adds to a new array, to our old array. Right, so let's do something. For example, let's say let's say a snapshot, and I set this to to-dos. All right, and maybe a snapshot is like a snapshot right now just points to the to-dos array, right? And maybe this is a snapshot, as the name suggests, is like a copy, right? And I may want to use this for like debugging purposes. Maybe I want to use this to like create some sort of an undo redo operation in the app. And if I go and here push directly to the to-dos, because both of these variables are pointing basically to the same place in the memory, what happens here is that the snapshot is also updated. So if you wanted to like see what was the original state of the app and then how it changed, that information is lost. What you can do instead is like if you change this to something like let, and then you go down here, and you update the to-dos variable by creating a new to-do. So you can say this is like a new array, like it's a new array, and I'm gonna give it everything that was in the to-dos, and in addition to that, I'm gonna give it a new array, a new to-do. All right, now this style allows you to basically like the to-dos variable has changed with a new element in it. But if you were to like look at the snapshot, that snapshot is still would hold the old to-dos, and so you would be able to, for example, look at what was the snapshot and what is the new state of the to-do and see like what happened in your application. Again, it's a bit of a stretch for me to try to argue like this is a better style. I just want to bring it to your attention that this is one of the differences. So I'm going to keep it try to align it with this idea of immutable data structures, because that's one of the pillars of functional programming. And maybe let's make this more pronounced. Let's make a function for this. Let's create something like const add to do. And so what this does is that, let's say, it will take the, well, let us take all of this. Well, I can take all of this. So say add to do, and maybe we pass the to do text to it. And so let's come up here and return this thing. And so the to do text comes here. Let's see if this still works. Yeah, still works. So, and then since it's just one return statement, you can really simplify this by taking this stuff out. Okay, so you get the to do text. You spread out whatever is the latest state of the to-dos, and you add a new to-do to it. And this way, the sort of the logic of updating the to-dos and this initial state of completed is also abstracted away. So this makes the implementation here cleaner for sure, right? Like add a new to-do and it returns, and so you overwrite the to-dos variable. And this is going to give us, well, a version that is more aligned with the idea of immutable data structures. You're going to see this idea in the future. For example, some of the famous libraries for front-end development like React, they make use of this idea of the state of like your web components. They should never be mutated directly. And so it's a good idea that we try to grapple with right now, and then we will develop it further and further when we progress through the course.